Hi everyone, this is the second video tutorial dedicated to AS hydraulics. In this video I'll tell you about the third step of learning AS hydraulics, and the third step is how to create your own schemes or your own diagrams, and how to work with them, how to calculate them, and how generally to work with all functions of AS hydraulics. Let's start. The first thing you should do is, of course, run AutoCAD, and let's start from creating new drawing. As I told in previous video, to load AS hydraulics to AutoCAD, you should at least once press calc scheme button in ribbon, in your ribbon. This will lead to loading AS hydraulics to AutoCAD memory. AutoCAD asks you if you trust this application. Of course you trust, and I trust too. So I press always load. Program consists of two modules, two files. I agree to always load both of them. And then you see a message about trial mode. And if you have a license, you of course want to activate your application. We go to main menu, AS hydraulics service activation. I have activation code, of course, because I created this application. I enter this activation code to activation window and press OK. Done. My instance of AS hydraulics is activated. So what can we do now? Now we can create our first scheme. Let it be rather simple in order to show how we do it in general. As I told earlier, first element of any scheme usually is a differential pressure source or pump. Let's start from differential pressure source. It's more simple object than pump. Press menu item differential pressure source. Select where to insert this object. Done. Then you can make double click to this object and see what parameters it has. Unfortunately, for the current moment, there are some issues with Russian letters. As you can see, almost all units for parameters are marked with question signs. This bug will be fixed later. Now I'll just tell you what these question signs mean and what all the parameters mean. First is uh, designation. Yes, designation. Uh, this is name of your element in your scheme. It may be DP1, it may be P25, anything you want. Next parameter, calc parse log x division. It's technical parameter. I won't explain it now. I don't see that it's not necessary, I think. Calc parse endpoints. This is important parameter for calculation setup. When you perform complex calculations, you want to get good tolerance. To improve calculation tolerance, you increase number of points for calculation. And the main parameter of differential pressure source is dH, or its differential pressure. The more is differential pressure, the more is flow in your scheme. Other parameters are filled by default. We won't change them now because it's not necessary. But I will tell you about the second important parameter that should be filled by user. It's absolute pressure on input of this element of differential pressure source. It's not necessary to fill it, but if you want to calculate pressures, absolute pressures in your scheme, you should fill it. Usually, value of this parameter is something like 1 bar or 1.5 bar. Let's just put here 1 bar. Okay, and the third important parameter of this element is temperature on the input and the temperature on the output of this object of differential pressure source. Why is it important? Because AS Hydraulics also performs temperature calculations, and if you want to calculate temperature distribution in your scheme, you should fill temperature on the output of this object. Well, let it be 20 degrees. Okay, setup of differential pressure source is complete. Then we insert the next object. We go to AS Hydraulics, scheme editing, scheme elements, and for example, let it be any hydraulic resistance, like such as two-way valve. We put it to our scheme. We can select the view of this valve this or this. This doesn't this takes no effect on calculations. It's just only appearance of this object. Let's see what parameters has valve, two-way valve. Two-way valve has such important parameters as KVS. In my application, it's called KV, but correct name for this parameter is KVS. These parameters shows which flow goes through this valve when the pressure drop on the valve is 1 bar. So by default it's 12 cubic meters per hour. That means that when flow through valve is 12 cubic meters per hour, the pressure drop on this valve will be 1 bar. We can change this value, but I suppose we will do it later. Now let's work with by default parameters. And the third thing you should do to complete your simple scheme is to connect two elements with pipe. AS hydraulics, scheme editing, menu item, connect two elements with pipe. So what should we do to connect two elements? First thing we should do is to select object. To select first object that will be connected with pipe. It will be more comfortable for me to change snap value to, for example, 2.5 millimeters. Oh no, this is English AutoCAD and units, I suppose, are inches. Let's change it to not important. We select first element and then program asks us to pick a point to which pipe will be connected. And then we select the second object and also pick point to which pipe will be connected on the second object. If you want to change snap settings, you do it, and now we see midpoint. Okay, the pipe inserted to drawing with the following parameters. Let's see. Diameter of the pipe. By default, it's 25 millimeters. K abs. This is. Give me a second, please. Roughness. This is roughness. of pipe. It it influences at pressure drop of pipe. Length of pipe, let it be 5 meters, and the other parameters we don't need to fill in, they will calculate automatically. Okay, and to set up our scheme, to make it more viewable, we can insert some inscriptions. For example, we select differential pressure source. We select parameter of this element that we want to see. Pick point where to insert inscription, and the inscription is inserted. You may have some issues, as I do now, with settings of text styles in your AutoCAD. I won't change these settings. I'll just set up text height. I'll just set up text height. Okay, now we see differential pressure of our source. Then we can insert inscription for pipe. Let it be pressure drop for pipe. It's not calculated yet. That's why we see these hashes. And we insert inscription to our drawing for valve. Select valve, press enter, select pressure drop. Also, the other interesting parameter of our scheme will be mass flow. Mass flow in this scheme will be the same for all elements, because this scheme doesn't have branches, so it's not important what object to select for displaying mass flow. Let's select our valve, select parameter GM. This is mass flow, and insert inscription somewhere here. Everything ready, and then we calculate our scheme by pressing IS Hydraulics Calc Scheme in Ribbon, or Schemes Editing. Oh, no. Calculation, calculate scheme, full calculation with flows, pressures, and temperatures. As I've shown earlier, to calculate scheme, you should select first element of scheme. This will be, of course, our differential pressure source in this scheme. Then we press enter. We have no other scheme to calculate, so we press enter again, and calculation starts. We confirm boundaries of calculation. And when calculation completes, we press enter once more, and we see flow in our scheme, and we see pressure drops on pipe and valve. And if we sum these two pressure drops, the sum will be equal to differential pressure of our source. Okay, to see what changes in the scheme if we change, for example, differential pressure of source, we change differential pressure of source, calculate scheme one more time. Agree to update screen, and we see that pressure drops and flow increase. All parameters increase. Well, that's all I wanted to tell you about how to create simple schemes. When you want to create more complex schemes, you may use other elements, for example, pump. Let's stop on pump a little. Pump has more parameters than differential pressure source. To set up pump parameters, you need to know 3 points of its characteristic, of its hydraulic characteristics. Where do you get them? Also, please notice that temperatures in our previous scheme have calculated too, and they have become 20 degrees as it was in source, in output of source. And also please notice that pressure calculation also was performed, and when we set up one bar at input of pressure source, we got 3.5 bars at the output of pressure source, and then after pressure drop on pipe we have 1.8 bars at the output of pipe. At the input of the valve we also see 1 and 1.8 bars, and at the output of valve we see 1 bar. So about pump, let me please show you how you get pump parameters. For example, any pump, we find it Let's interrupt for a second. I'll find curve for some example pump and we'll continue.